Okay. Bismillah ar-Rahman ar-Rahim. Inshallah, we'll continue in this 4.5. We want to this problem. The graph of this function has one vertical and two horizontal. He's talking about vertical asymptotes, horizontal asymptotes. So you need to decide how many we have. Now, vertical, we know what are the possible ones. The zero denominator x equal half, and it is a vertical asymptote. Why? Because it will be non-zero here. It will be non-zero over zero, so for sure it will go either plus or minus infinity. You need to check this. I will leave it for you to check. Now because I'm concerned about horizontal in this problems, in this list of problems. Okay, so for the horizontal asymptotes, I need to check the limit as this goes to infinity, and the limit x goes to minus infinity as usual. I take common factor, x squared. I have 1 plus 2 over x squared. Take x, I have 2 minus 1 over x. Okay, check 2x minus half, minus 1. Everything is okay. I take, this is absolute value of x, square root 1 plus 2 over x squared over x, 2 minus 1 over x. And that what will make a difference now. As x goes to infinity, this will be x. Alas, cancel. Substitute, you get half. Now, if you want to check the limit, as it goes to minus infinity, this will be, the absolute value of x will be minus x over x, 2 minus 1 over x, cancelled. You have what? These are zeros, 0, 0, so you have minus half. So you have two horizontal asymptotes, y equal half, y equal minus half, and one vertical, which is x equal half. That's the solution. You know, to check, they have piecewise function in this case. I'll check y equal k, horizontal. So check the limit as it goes to infinity. Since it's piecewise, x goes to infinity, معناها I am in which I'm x greater than 4, I mean I am in this function. So we'll take this function. You can deal with it as same degree, which is minus 1, or you can do it by dividing by square root of x. 2 over square root of x plus square root of x over square root of x, 2 over square root of x minus square root of x over square root of x. For sure, this goes to 0. This goes to 0 as it goes to infinity. So you have 1 over minus 1, which is minus 1. So you have y equal minus 1. This is one of the horizontal asymptotes. Now we'll do the same as it goes to minus infinity. Be careful. Minus infinity, I'm here. So this will be my function. X cubed plus x minus 3 over 8x cubed minus 3 to the power 1 over 3. The function x to the power 1 over 3 is a continuous function, so I can take the limit inside. So this will be limit s goes to minus infinity of this one, all to the power 1 over 3. This is what? Same degree. So the limit, you can find it easily. It will be 1 over 8 to the power 1 over 3, which is half. So y equal minus half is another horizontal asymptote. Is looking for the sum minus. No, here we have half. Well, it's not minus half. So it will be minus 1 plus half. That will be minus half, which is this answer. And this one, if we simplify this, actually this is about vertical asymptote, this is okay. X plus 2, x, here I have what? X squared plus x minus 2, which is x plus 2 times x minus 1. Okay, f has a horizontal asymptote at y equal 1, y equal 2. This is wrong, because they have the same, this degree is less than this, so the only horizontal asymptotes we have is y equals 0. So this is wrong. Has a vertical asymptote x equals 0, also it's wrong. So this is wrong. X goes to minus 2, actually it will be a number. It will not be infinity or minus infinity. So this is wrong. So the only case which is correct has a vertical asymptote at x equal. Now he has a graph. I think we did it in 2.2, but let me do it again. X goes to 0. X goes to 0. Here, left or right, I'm going to infinity. So this is correct. It goes to -3. This does not exist. It goes to 1. It goes to 1. I'm getting to this value, so it's 1. It goes to 4. I'm not going this. I'm going to this, so it is 2, not 1. It goes to minus infinity. It's not infinity. It's -1 from here. Goes to infinity, minus infinity. I'm going to -1. So this is the only correct, and this is all of these are wrong. Same thing, I have a graph. I want to ask some questions. X goes to 0. For sure, it goes to minus infinity, either from both sides. X goes to -2 here, so it does not exist. Right not equal left, huh? Right not equal left. X goes to 2. 2 is here, so it's not -1, it's -2. So this is -2. X goes to 1. X goes to 1, I'm getting a value, which is -3. X goes to infinity is not 1, is not 0, it's 1. Goes to infinity, I am here, which is like asymptote, y equal 1. So all of this is wrong. The only correct is A. Which one of the following statement is false? We know if the limit is infinity, the other one is infinity. We took many examples where the difference is not, we agreed that infinity minus infinity is undetermined. So it can be anything. It cannot be 0. So this is false. A function can have two different horizontal asymptotes. Yes, we did many examples. If it's continuous, it means the limit as x goes to 5 is equal f at 5, which is 2. And then this limit equal this. Just you need to do some, substitution. Let t equal 4x squared minus 11. So that will be limit f of t. As t goes to what? If x goes to 2, I have 4 times 4, 16 minus 11, and t goes to 5. Which is, since the function is continuous, that will be 2, which is this one. So this is correct. A function can have infinitely many, yes. If it's continuous, then absolute value is also continuous. Yeah, because absolute value will do nothing. If this is the function is doing something like this. Let me say doing something like this, going up, going down. What will do the continuity, the absolute value will do what? Just say make this part positive. This part will be positive. So it will not change the continuity. So this will be continuous. It will be correct. Now we talk about this function. We want to discuss vertical asymptote, horizontal asymptote. We need to simplify it as usual. That will be x minus x plus 2 times x minus 1 over x minus 1 times x plus 1. Make it plus 1, and this is minus 1, better. So we see it easily. Very clear at 1, we don't have horizontal or vertical asymptote. At -1, we have, you can check through the limit. Since I have 0 and I have in the numerator non-zero. Now for the horizontal asymptotes, we need to be careful. I need to check the limit. X goes to infinity for this function. Yeah, the best way to deal with it, to see it easily, also for the other one, is split it. This is 1, same degree, and this is e to the power minus infinity, which is 0. So 0 times 1, which is 0. So for sure, I have one horizontal asymptote. Check the other one. Limit s goes to minus infinity. I'll do the same trick. I split it. This is same thing. It will be 1, but this will be infinity, e to the power infinity, which is infinity. So the answer is infinity. So how many horizontal asymptotes? I have only 1. Y equals 0 is the only horizontal asymptote. So I have 1 vertical, 1 horizontal, so this is correct. I want to do this limit. If we substitute, you have infinity minus infinity, so you need to be careful. So what you will do, you need to simplify y over 1 and do the rest of the calculation. Just rationalize what you will get. Limit x goes to minus infinity of 4x squared plus cx minus 4x squared. I will do x squared common factor to save time, c over x minus 2x. This is cancelled. This will be cx. This will be absolute value of x. Be careful here. This will be minus x since this goes to minus infinity. So this will be limit x goes to minus infinity. Cx, I'll take x common factor, will be minus 4 plus c over x. I took minus, so this is plus 2. I took minus here as a common factor. So this will be minus, it will be plus plus. Okay. So this is cancelled. So we have what? Minus c over 4. Yeah, this is square root of 2. This is 0. 2 plus 2, which is 4. So this is the answer. This one, we want the limit x goes to infinity. So we'll do it by factoring. This is take x squared. You have 4 minus 1 over x plus 5 over x squared minus 3x over x 1 plus 1 over x. That will be limit x goes to infinity of what? I took square root x squared, which is the absolute value of x, which is x. Can make it x quickly. That will not make a big difference. If it is minus, I need to be careful. Okay. So take a limit, take a common factor to cancel it with the denominator. As-salama. You have what? This is 0. This is 0. This is 0. 2 minus. ما في x هنا خلاص. I took x as a common factor, so there is no x. 2 minus 3 minus 1 over 1. This is minus 1, which is this one. The horizontal asymptotes, easy. Same degree, so it will be 1 over minus 1, so y equal minus 1. Either limit goes to infinity or minus infinity. Since it's a rational function, very clear. This one, you need to take common factor. Will be limit x goes to minus infinity. X to the power 6, 9 minus 1 x to the power 5 over a half x cubed, 1 plus 1 over x cubed. Be careful, square root of x squared, x to the power 6 is absolute value x cubed. And that is, since this goes to minus infinity, minus x cubed. So that will be limit x goes to minus infinity, minus x cubed, square root 9 minus 1 over x to the power 5 over x cubed, 1 plus 1 over x cubed, cancelled. This goes to 0, this goes to 0, so it will be minus 3 over 1, which is minus 3, which is this answer. Yeah, be careful with cosine 3x or cosine in general. The cosine function, if you notice, you start, you don't know where to stop. Because of that, I cannot say there is a value it will reach. It will go up and down, I don't know. So it will oscillate. So the limit does not exist. This is 2 will not make a difference. The only difference is cosine. Cosine infinity is, does not exist. This one do the same. Simply just take common factor. X to the power 6, 4 minus 1 over x to the power 5, similar to the one we did before. 1 plus 2 over x cubed. Let me do it quickly, but now x goes to minus infinity. So square root, absolute value of x cubed, I think it was the same, minus x cubed. So that will be limit, x goes to minus infinity, minus x cubed, under the rest, over x cubed, 1 plus 2 over x cubed. So that these cancelled, we're getting minus 2 over 1, which is minus 2. What is this answer? Which one statement is true about this? Very clear. This one take x, 4x plus 5, x, 2x plus 1. خلاص واضح. How many vertical asymptote? Only one. X equal minus half. This is non-zero. خلاص. So I have vertical asymptote. Horizontal asymptote also only one. Same degree. Y equal 4 over 2, which is 2. So I have y equal 2, x equal minus half. Easy ones. Here same thing. Vertical. X equal 2. This is 0. This is non-zero. خلاص. For sure this is vertical asymptote. Horizontal. I need to check limit. X goes to infinity and x goes to minus infinity. So this is will be what? 2x squared minus 1 over x minus 2. And that will be square root. I need the limit. Don't forget the limit. S goes to infinity. I'll do common factor. X squared, 2 minus 1 over x squared. Do it also in the denominator. That will be limit. X goes to infinity. Square root of x squared, which is absolute value of x. So I have absolute value of x. So let's say we want it for the minus infinity also. For x, 1 minus 2 over x. Okay, this for absolute value, for x goes to infinity, I have x. So this is cancelled. So I have what? Square root of 2. Square root over 1, which is square root of 2. For limit, x goes to minus infinity. What's the difference? This will not be x. It will be absolute value of x, so that will be minus x with the same in the rest. Cancelled. You have minus square root of 2. معناها this is the vertical asymptote, horizontal asymptote, y equals square root of 2, y equal minus square root of 2. This is the horizontal asymptote. Find the vertical asymptote, horizontal asymptote. First, you need to simplify the function. Common factors, common denominator, I mean, x plus 1. It's here x plus 1, x squared minus 1. That will be what? X minus 1 times x plus 1, x plus 1. واضح. Vertical asymptote x equals 0. هذه cancel. You don't have vertical asymptote. Horizontal asymptote, same degree. X squared. So y equal 1. These are the only horizontal asymptote. X goes to infinity of this one. If we substitute, you have infinity minus infinity. So it means you need to do something over 1. Check. Plus x. That will be limit. S goes to infinity of what? X squared plus 4x minus x squared. This I will take x squared common factor. Let me make it quick. Plus x. This is cancelled. Now still we have 4x there. This is, I have square root of x squared, which is the absolute value of x. Since this goes to infinity, this will be x. So take x out. Plus x. We'll take it as a common factor. Plus 1. Cancelled. This goes to 0. So I have 4 over 2, which is 2. So this is the limit. Yeah, this is easy one. Rational function. This will be x minus 2, x plus 1. واضح. Vertical asymptotes. We have x equal 2. Since this is cancelled, so this is the only one remaining. Horizontal asymptote, same degree, so y equal 1. Find the horizontal asymptote of each function. I make it in 2 slides. Okay. The first one, you want the horizontal asymptote. Okay. So if I want to check limit x, I start with minus infinity for a reason. And if you notice, for minus infinity, it will be minus infinity squared, which is infinity, plus 4 infinity, square root infinity. So it's infinity minus infinity, which is infinity. So we have no horizontal asymptote from this side. We'll go to the other one. If we substitute, you get what? Infinity minus infinity. There's a problem. So it means I need to simplify it or rationalize it, make it over 1 and rationalize it, and do the calculation. That will be limit x goes to infinity, x squared plus 4 minus x squared over this. Cancel. So I have 4. And the denominator is what? This is infinity plus infinity. So 4 over infinity, that will be 0. So the only horizontal asymptote is y equal 0. This is the only horizontal asymptote. The second one, square root 4x squared plus 3 minus x, correct? Over x minus 1. We'll do limit x goes to infinity. For this function, we'll take x squared common factor, 4 plus 3 over x squared minus x over x minus 1. And that will be what? This is square root of x squared, the absolute value of x. That will be absolute value of x. Square root 4 plus 3 over x squared minus x. Here we'll take x, 1 minus 1 over x. Here, this one will be x. So I can take x as a common factor. X, 4 plus 3 over x squared minus 1 over x, 1 minus 1 over x. This is cancelled. So you have 2 minus 1, which is 1 over 1, which is 1. This is one thing. The other thing is limit x goes to minus infinity. I'll take it from here. It will be absolute value of x, square root 4 minus 3 over x squared minus x over x, 1 minus 1 over x. Khalas, this is minus x. So it means what? I take minus x common factor. What is the remaining? This is plus 1. I took minus x common factor, so this will be plus 1 over x, 1 minus 1 over x. So this is cancelled. The rest is just substitution. Minus, but it will be 2 plus 1 over 1, so it's minus 3. So I have y equal 1, y equal minus 3. These are the horizontal asymptotes. Find all vertical asymptotes if they exist of the for the following. Okay. Vertical asymptote x equals 0. It's 0 here, it's not 0 there. So it will be vertical asymptote. You can check a limit from left or right. I will wait for you. Horizontal asymptote, we'll check the limit as this goes to infinity. You have this. So what I will do, rationalize. That will be limit x goes to infinity, x squared plus 2 minus x squared over 2x, square root x squared plus 2 plus x. This is cancelled, x squared plus 2 minus x squared. So I have 2, this is infinity, infinity times infinity, I have 2 over infinity, so this is 0. Now check limit x goes to minus infinity for the same thing. Yeah, it will be the same, huh? Rationalize it. Yeah, because everything will be gone. Wait a minute. Oh, be careful. No. Yeah, let me continue. See what will happen. I cannot do it here. It will be infinity over minus infinity. So it's infinity, infinity, undetermined. Do this. I have what? X squared plus 2 minus x over 2x. This will be infinity minus infinity. That means what? We did the infinity. We have 0. But the minus infinity, it will be this x squared 2. I have 2x here. Square root x squared plus 2 plus x. So that gives me 2 cancelled 1 over x times this, which is what? Which cannot be done. Okay, so let me think about another way. Yeah, actually I can do it from the beginning. Yeah, for both. I think it will be easier. Yeah, I can do it for both from the beginning, which is take the common factor. What I did for x goes to infinity, I think is correct. Remember, it was 0. So now we'll double check it. This is, I can do it for limit x goes to 0, x goes to infinity. I can take x squared common factor. So I have 1 plus 2 over x minus x over 2x. Yeah, I think that will do it. I have absolute value of x, 1 plus 2 over x minus x. Don't forget, this is x over 2x. So that will be limit x goes to infinity, x times the rest. This will be minus 1 over 2x. This is cancelled. So you have 1 minus 1 over 2, which is 0, which is the same answer. But now, as this goes to minus infinity, this absolute value of x will be minus x over 2x. So if I take x as a common factor, it will be what? I'll take minus x as a common factor. Who cares? It will be minus x square root 1 plus 2 over x plus 1 over 2x. This is cancelled. So you have minus 2 over 2, which is minus 1. So you have 2 horizontal asymptote. Y equals 0 and y equals minus 1. And vertical asymptote, I have 1. X equals 0. He's talking about horizontal and vertical. Vertical, very clear, x equal 1. Since I have 1, this cannot be 0. But 1, so I have 0 over 0, so for sure it goes either plus or minus infinity. Now, for x goes to infinity, take x squared common factor, it will be 4 plus 3 over x squared minus x over x, 1 minus 1 over x, and that will be limit x goes to infinity. Don't forget, when this is taken out, it will be x times the root minus x over x, 1 minus 1 over x. I take x as a common factor in the numerator. What you are getting, 4 plus 3 over x squared minus 1 over x, 1 minus 1 over x, مع السلامة. That will be 2 minus 1 over 1, which is 1. So I have y equal 1. This is a horizontal asymptote. Check limit, x goes to minus infinity for the same function, except here I have absolute value of x, so that will be minus x square root 4 plus 3 over x squared minus x over x, 1 minus 1 over x. So that will be limit x goes to minus infinity. Take minus x common factor. It will be 4 plus 3 over x squared plus 1 over x, 1 minus 1 over x. Cancelled. You have minus 2 plus 1 over 1, which is minus 3. So this is the answer. Two horizontal asymptote, y equal 1, y equal minus 3, and 1 vertical asymptote, which is x equal 1. Huh? X equal 1, this is the vertical. Horizontal, y equal 1, and from here, y equal minus 3. These are the horizontal asymptotes. This one, you want to find the limit. If we substitute, you have infinity minus infinity, so you need to be careful. Over 1, rationalize. you will get 4x squared plus 4x minus 4x squared. I take x squared common factor, have 4 plus 4 over x minus 2x, and that will be limit x goes to minus infinity. هذه مع السلامة. You have 4x. Here I take it absolute value of x minus 2x. This is minus x. So if I take minus x common factor, I'm getting what? Square root 4 plus 4 over x plus 2. Yeah, take minus x, this is minus 1, so there's plus 2. This is 0. This is x cancelled. You have what? 4 over minus 2 plus 2. So it will be minus 1, which is this answer. The function has 2 horizontal and 1 vertical. Why is that? If you solve this, you have square root x squared plus 3 minus 2 equals 0. So you have x squared plus 3 equal 2 equal 4. So you have x squared minus 1 equals 0. So you have x equal plus or minus 1. Okay. But for the, so you have the denominator, yeah. X equal 1, it will not be, since it will be cancelled by this one. But you need to check it. Limit x goes to 1 of this function. Let me do it. Minus 1, it will be okay. Minus 1 is a vertical asymptote. And it will be non-zero over 0. خلاص. And the 1, let me check it. Limit x goes to 1 of this function. What I will do to see it, I just, if we substitute, you have 0 over 0, simplify it or rationalize it. You are getting what? X minus 1. Here we have what? X squared plus 3 minus. Okay. This is x squared minus 1, so that will be killed. And you are not getting infinity. This limit will be what? 1 plus 3, 4, 2 plus 2, 4 over 2, which is 2. So we don't have that. We have only vertical asymptote from x equal minus 1. This is not a vertical asymptote. Horizontal, I need to check limit. X goes to infinity. Okay. What you have x, 1 minus 1 over x. Here we have x squared, 1 plus 3 over x squared, minus 2. Okay. Okay, let me see what will happen. Yeah. That will be limit x goes to infinity. X 1 plus 1 over x. Here I have absolute value of x times this minus 2. Yeah, you can think of it same degree, huh? Oh, but it's not right. No, it will be plus or minus here. Right. It will be the same idea. Okay. So now let me continue. See what will happen. Limit x goes to infinity. X 1 minus 1 over x over, here I have x, square root 1 plus 3 over x square minus 2 over x. So x cancelled. So you have 1, this is 0, this is 0, this is 0. This 2, I make it 2 over x times x. So I have 1 over 1, which is 1. So I have 1 horizontal asymptote, y equal 1. Now limit, x goes minus infinity for the same thing. So I have, instead of x minus x, so I have x, 1 minus 1 over x, over minus x. 1 plus 3 over x squared minus 2. So I took minus x as a common factor. I'm getting this plus 2 over x. If I took minus x, so I have plus 2 over x. So this is cancelled. This is 0. This is 0. This is 0. So I have 1 over minus 1, which is minus 1. So I have another horizontal asymptote, which is y equal minus 1. So I have 2 horizontal asymptotes, 1 vertical asymptote. The horizontal asymptote of this, very clear, same degree, y equal minus 1. No need to do anything. Yeah, I don't know why I have this. It's there. So by mistake, I have it two times. Okay, so I have f of x. Let me rewrite it. 3 minus x cubed, absolute value of x cubed minus 3. Vertical asymptotes will come from where? From the zeros of this. That means absolute value of x cubed equal 3. So that means absolute value of x equal cube root of 3. So x equal what? Plus or minus cube root of 3. For vertical asymptote, for vertical asymptote. If x equal cube root of 3, then that will make a problem. It will be 0 over 0. Huh? So to check the limit, I think you will not get vertical asymptote. Check. However, if x equal minus cube root of 3, okay, minus cube root of 3, that will be 3 plus 3. So I have non-zero over 0. For sure, I have vertical asymptote with this. This is vertical asymptote. This would make it 0 and 0. Huh? X cube root of 3, it will be 0, 0. So which is 3 minus 0 over 3 minus 3. So we will not get vertical asymptote. Check it. Huh? Let me deal with the horizontal asymptote. Now with the absolute value. Limit x goes to infinity. Also, it will be easy. 3 minus x cubed over absolute value of x cubed minus 3. Careful. X goes to infinity, معناها this is positive. خلاص. That's the end of it. X cubed minus 3. So what is this limit? Same degree, minus 1. Limit x goes to minus infinity for the same function. This time this is negative. So there will be a minus sign. 3 minus x cubed over minus x cubed minus 3. Same degree, coefficient 1. So you have 2 horizontal asymptote. Y equal minus 1, y equal 1. These are the horizontal asymptotes. And 1 vertical asymptote. So this is the answer. What will accept is true about this function. Vertical asymptote, no, everything is defined. We know that tan inverse is defined everywhere. For any value of x, the function is defined. So we have no problem with x. The problem only with the horizontal asymptote. So you want to check limit x goes to infinity of this tan inverse x minus square root x plus 7. With minus infinity, it will be easier. X goes to minus infinity, it will be easier. Why? Because this will be what? Minus infinity minus infinity. X squared will be infinity, so it will be minus infinity, which is tan inverse of minus infinity. I know it's minus pi over 2. This is easy. The other one, you need to do it the long way. First, I need to do this. How to do that? Rationalize. I think it's not that difficult. I think it will be 0. Let me check. That will be limit x goes to infinity, x squared minus x squared minus 7 over this. So this will be minus 7. This is infinity. Minus 7 over infinity, which is 0. So we have two horizontal asymptote, y equals 0 and y equal minus pi over 2. So this is the answer. Yeah. 2ax plus 3e2x over e2x minus e3x. Vertical asymptotes, I need this to be equal to 0, which implies e2x times ax minus 1 times 1 minus ax equal 0. This cannot be equal to 0. معناها ax equal 1 معناها x equal 0. Take ln. ax equal ln 1. معناها x equal ln 1, which is 0. We notice that at x equals 0, this will be 2 plus 3, non-zero over 0, so we have vertical asymptote x equals 0. خلاص. Horizontal asymptote, I need to check limit x goes to infinity and minus infinity. Oh, yeah, x goes to minus infinity, easy one. No, it will be what? No, it will not be easy. So it means I need to simplify the function first. Yeah, very clear. I can take e2x or ex in the numerator. You have 2 plus 3ax. Take e2x in the denominator. You have what? 1 minus ax. This is cancelled. You have e minus x. Well, e of x, you have it in the denominator. So you have 2 plus 3ax over ax, 1 minus ax. خلاص. Now check the limit. It goes to minus infinity. That will be what? Of this. You started with minus infinity and it will be easier. That will be 2 plus 3 times 0 over 0, 1 minus 0. So I have non-zero over 0, so this does not exist. Goes to infinity or minus infinity, check it. Who cares? But it will not go to a value. Limit x goes to infinity, the same thing. What I will do, I will take e to the power x in the numerator. The remaining is what? 2e minus x plus 3. This is ax, 1 minus ax. خلاص هذا cancel مضبوط. This is 2 plus 3ax. This is same. Now substitute. You have this is 0 and this is infinity. So you have 2 times 0 plus 3 over 1 minus infinity, which is a number of infinity, so it will be 0. So I have only one horizontal asymptote, which is y equals 0. The equation of the horizontal asymptote. They want the horizontal asymptote. Take ln. This is very clear. خلاص. I need to find the limit. X goes to infinity. That will be ln this. Infinity or minus infinity, I can take it inside. So that will be ln of this limit. Either x goes to infinity or x goes to minus infinity, give me the same thing, which is the same degree. So it will be ln half, which is ln 2 to the power minus 1, which is minus ln 2. I think this is the way it was written. So y equal minus ln 2 is the horizontal asymptote. Yeah. So dy equal minus 2 is a horizontal asymptote. Find A. It means the same degree. the same degree. So I have a over a plus 1. This is for sure same degree, cubed. So horizontal asymptote a over a plus 1 equal minus 2. Do the calculation. معناها a equal minus 2a minus 2. So 3a equal minus 2 means a equal minus 2 over 3, which is this. Easy one. This limit, which is you need to take common factor. Limit x goes to minus infinity. Take x square, 9 minus 2 over x square. Take x, 6 plus 1 over x. This take it absolute value. So it will be minus x. So that will be minus x under the square root of this over x. 6 plus 1 over x. So you have what? This is cancelled. You have minus 3 over 6, and here minus half, which is this one. Same idea. We notice this one, and we see it many times. X square, 4 minus 1 over x square, over take x, 1 over x minus 2. So that will give me what? This is square root of x square, absolute value of x equal minus x, since x goes minus infinity. So that will be limit x goes minus infinity minus x times the square root over x times this. Cancelled. You have minus 2 over minus 2, which is can take can take absolute value of x outside from both and cancel them, or you can make it easier like this. Take the limit inside. This everything is defined. The same degree. So it will be square root, what? 1 over 4. No, same degree, 1 over 2, which is 1 over root 2, which is this. Yeah. X goes to infinity of this. You need to rationalize it. You have infinity minus infinity. You have infinity minus infinity, so you need to rationalize it. See what will happen. Seems to be complicated. I don't think so. Inshallah, we'll reach the answer quickly. Limit x goes to infinity. X squared plus 2x plus 3 minus x squared minus 1 over all of this. So this is cancelled. You have what? 2x plus 2 over all of this. Now, still, I think it needs more calculation. It will be limit is goes to infinity. Here I take x, 2 plus 2 over x over, and I take x squared common factor. You have what? 1 plus 2 over x plus 3 over x squared, which is go 0, 0, 0. Plus take x squared common factor. We have 1 plus 1 over x squared. This is will be square root x squared equal absolute value of x equals x. So I can take x as a common factor. Since I'm going to infinity, I have nothing to worry about. That's it. I have 1. I have x, take it common factor, 1 step, plus the other root, 1 plus 1 over x squared. Add cancelled. 0, 0, 0. So you have 2 over 1 plus 1, which is 1, which is this answer. I know I forget this. Let me do it here. If we substitute, you have infinity minus infinity. So rationalize it. That will give you what? Limit as goes to infinity, x squared plus x plus 1 minus x squared over this. So this is cancelled. Do the same thing, take x common factor, have 1 plus 1 over x. Here I will take x squared inside the square roots, 1 over x plus 1 over x squared plus x. Now this will be square root x squared, absolute value of x, which is x, since x goes to infinity. So you take x as a common factor, and that's it. You get the answer. X, the rest, plus 1, cancelled. So you have 1 over 2, which is this. Yeah, and I'll stop with this one. If you simplify it, this is, you need to do it by grouping. So it will be x minus 1 times x squared plus 1 over x cubed, 1 minus x, 1 plus x. Removable, very clear, at 1, x equal 1. Infinite discontinuity, we have at 0 and minus 1. Very sure this is will go to 0, this is will go to a number. Vertical asymptotes, x equal 0 and x equal minus 1. This will go to 0, this will be a number. Horizontal asymptotes, y equals 0. This is degree 3 over degree 5. Yeah, I think I will stop here.